Today we're going to take a look at some of the practice problems you've done with multi-step equations. We're going to look at numbers 3, 5, and 9 from yesterday, and numbers 6, 12, and 18 that are coming up today. All right, here's a look at problem number 3. We want to get all of our x's together on one side, and we're going to get all of our constants or our numbers together on the other side. Constants are numbers without variables. So to get all of our x's together, I'm going to start by looking at this 7x. I need to move it over here, so I want to take it away from both sides. I notice that it's positive, so I need to subtract 7x. Whatever I do to the right side, I have to do to the left side. 8x minus 7x leaves me with 1x. Then I still have this minus 2. We just bring that part straight down. My equal sign is in the middle. And over here on the right side, I have negative 9 left. And then I have positive 7x minus 7x, which is 0. So we don't need to write that part. Now we want to get all of our constants together. So I'm taking a look at this negative 2 right here. Notice I said that was a negative 2 because of this minus sign. Remember, if we want to get negative 2 to 0, we need to add 2 to it. We want to do that inverse operation. So I'm going to add 2 and add 2 to both sides. So I get x left over here. Negative 2 plus 2 cancels out. And I have negative 9 plus 2. Well, negative 9 on the number line, if I add 2 to it, I'm going to the right 2 spaces. And that would be negative 8, negative 7. So x is equal to negative 7. Next, we're going to take a look at number 5. I already have my constants over on the left side, and there are no constants on the right side. So we're going to group all of our constants over here. Remember, those are numbers without variables. We're going to group all of our m's over here on the right side. So I'm taking a look at this 4m right here. It's a positive number, so I need to take it away from both sides. What I'm left with is this minus 4. Remember, we carry that sign with it. And then I get 4m minus 4m. Well, if I have 4m's and I take 4m's away, I have 0 m's. So I have negative 4 equals 0. I want to ask myself, is this true? Does negative 4 equal 0? The answer is no. This is not true, which means this equation has no solution. I'm going to take a look at number 9 next. Notice I have my constants over here, so we'll keep our constants grouped over on this side. And over here, we're going to end up grouping our x's a little later. So I want to start by looking at these parentheses. I've got some parentheses over here on my right-hand side. So I need to use my distributive property to distribute this negative. When we see a negative out in front of parentheses, we want to pretend there's a 1 there. So I've got negative 1 distributes to both of these numbers. I'm not doing anything to my right side right now, and I've got negative 1x plus negative 4. We're going to now work on getting all of our constants together. So I'm going to look at this negative 4 here. Remember, negative 4 plus 4 is equal to 0, and that's my goal. So I want to add 4 to both sides. I have negative 8 plus 4. If I'm looking at a number line at negative 8, I move 4 spaces to the right to add 4, and that lands me at the space negative 4. So negative 4 is equal to negative 1x. Well, I still don't have x all by itself because it's got this negative 1 in front of it. So we need to divide both sides by negative 1. Remember, we're looking at inverse operations. This is negative 1 times x. So we do the inverse operation to undo that multiplication. Over here, I've got negative 4 divided by negative 1. That's positive 4. And over here, I have negative 1x divided by negative 1, and a negative 1 divided by a negative 1 cancels out and leaves me with just x. X is equal to 4. We're looking at problem number 6 now. This is the problem p minus 1 is equal to 5p plus 3p minus 8. I need to get all of my p's on one side and all of my constants on the other. I'm going to choose this side for constants, and I'm going to choose this side for p's. So the first thing I notice here is that I have 5p and 3p. Well, 5p and 3p both have p's, so they're like terms. We want to rewrite this equation combining these like terms. If I have 5p's plus 3p's, I have 8p's all together. Now I have the equation. These are both equal to each other. P minus 1 is equal to 8p minus 8. I'm getting all my p's together on this right side. So I'm going to look at this p right here. It's positive. I can treat it just like a number and subtract it from both sides. So I'm left with negative 1 is equal to 8p minus p. I take away 1p. I have 7 p's left. So now I have negative 1 is equal to 7p minus 8. I'm going to work on getting my constants all over here on the left side together. So I'm looking at this minus 8. I want to do minus 8 plus 8 to get that 8 to be equal to 0. If I'm going to add 8 to both sides, I get negative 1 plus 8. That leaves me with positive 7 is equal to 7p. I'm going to bring this up here to finish this problem. 7 is equal to 7p. P is not by itself. There's this invisible multiplication that we can't see. So we need to divide both sides by 7. Well, 7 divided by 7 gives me 1 on both sides, so P is equal to positive 1. Looking at problem number 12, we notice we have a negative sign outside some parentheses to get us started. Negative 7 minus 4x is equal to 9. So we're going to put this 1 here so that we know to multiply negative 1 by both numbers inside the parentheses using the distributive property. I've got negative 1 times 7 gives me negative 7. And negative 1 times negative 4x gives me positive 4x. So now I have negative 7 plus 4x is equal to 9. I notice I only have x's on the left side, so I'm going to gather my x's on the left and my constants on the right, which means I need to do something with this negative 7. Remember, I want to zero it out, so I'm going to add 7. Whatever I do to the left, I have to do to the right. So these cancel out. I'm left with positive 4x. And then I get 9 plus 7, which is 16. X is not quite by itself. We have 4x, which is the same as 4 times x. To undo that multiplication, we divide. We have to do it to both sides. So 4 times x equals 16. That means x must be equal to 4 because 16 divided by 4 is 4. All right, the last problem we're going to look at today combines all of the things we've learned this week. We've got distributive property and combining like terms and solving equations with variables on Well, actually, the variables are only on one side, so let's get started. Notice these parentheses, so we're going to start with the distributive property. I've got negative 3 times 4x and negative 3 times 3. That's negative 12x plus negative 9. And then over here, I've got 4 times 6x, that's 24x. And then 4 times 1, that's 4. And all of that is still equal to 43. So now looking at this equation, I've got like terms, negative 12x and 24x. Negative 12 plus 24 is positive 12, and those are x's. And then I have negative 9 and positive 4. Negative 9 plus 4 is negative 5. So now I have 12x plus negative 5 is equal to 43. I'm going to gather my x's over here on the left-hand side because they're already there. So I want to move my constants to the right-hand side. That means that I need to work with this negative 5. Remember, I want to zero it out, and I know that negative 5 plus 5 is equal to 0. So I want to add 5 to both sides. I'm left with 12x here is equal to 48. And this is 12 times x, so our last step is to undo that multiplication with division. They cancel out over here. I'm left with just x. And 48 divided by 12 is 4. So x is equal to 4.